Hi, hello everyone. This is your educator, your tutor, your friend Sanjay Vishwakarma. I welcome you all to yet another session of We Learning. We Learning is a platform which focuses on providing right to quality education for all. Do watch this session. If you like it, do press the like button and share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. All right. Also visit our website www.we-learning.in. All these sessions you will be getting there. Along with that, you will be getting lecture notes in PDF format. You can go download them. They'll help you a lot. Okay, do check it out. Now, without any delay, let's get started with today's session. We were doing magnetism, moving charges and magnetism, and this is lecture number 4. In this lecture, we are going to talk about cyclotron. Very important. Okay, and very interesting also. We'll see the principle, construction, working, uses, and limitations. Okay. Now, first of all, what is cyclotron? Cyclotron, something like cycle, electron, right? If I join them, then cyclotron comes. You will understand. Once I'll tell you about the machine, then you'll understand. Before that, let us see. It is a machine used to accelerate charged particles to high speed, to high energies. Clear? Any charged particle, if we want to accelerate to a very high energy, to a very high speed, then we use cyclotron. Now, why do we need to accelerate any charge? That you will understand when we will study nuclear reactions, right? Any charge is bombarded with the nucleus for the radioactivity, for nuclear reaction to happen. So that's when we need charges with very high energy. Okay? So high-speed charged particles are used to bombard nucleus to study phenomenon like radioactivity. All right. Now the question is how to get highly speed particles, charged particles with a very high speed. How do we get that? Now, till now we have seen that if a charge is there in magnetic field or electric field, it experiences force. See, if I want charge to be accelerated with very high energy, we need to give it acceleration. For very high speed, we need to give acceleration to the charge. For acceleration, a force should be applied on the charge. The charge should experience force, right? Now, the two kinds of forces what we have studied till now is magnetic force and electric force. If a charge is in magnetic field, it experiences magnetic force. If a charge is in electric field, it experiences electric force. Now, in which field will it speed up? If I ask you, what do you think if a charge is in magnetic field, will its speed increase? Remember, if a charge is kept at rest in a magnetic field, the charge does not experience magnetic force, right? The charge does not experience magnetic force. That means no acceleration, no velocity. It will be at rest only. And if the charge is moving perpendicularly to the magnetic field, it starts doing rotational motion, uniform circular motion. Correct? If it is going with speed v, it continues to revolve with speed v. The speed doesn't change. No doubt the velocity is changing. Why? Because the direction of speed is changing. Correct? Because of which it is able to do circular motion, but speed remains same. So that means in magnetic field, the speed doesn't change. If it is going at some angle also with the magnetic field, still it will do helical motion with a constant speed. The speed doesn't change. Velocity changes because the direction is changing, but the speed doesn't change. Now we need to accelerate the charged particle at a very high speed. Now, if the charge is in electric field, will it get accelerated to high speed? Yes. We have studied that if a charge is kept at rest in an electric field, it experiences force that is QE in the direction of electric field. In magnetic field, charge gets deflected. In electric field, charge gets accelerated. Clear? Always remember. Now, suppose there is an electric field. Now, if there is a charge, if it is a positive charge, it will experience force QE in this direction. That means there is an acceleration that is QE by m in this direction. So for more duration, if this charge is present in this field, for more duration, the acceleration will be there on this charge. That means it will gain more speed. Now for getting this electric field, how do we get the electric field? How do we get the electric field? Suppose there are two plates. If I charge these plates, let's say here there is positive charge, here there is negative charge. Clear? So what will be the direction of electric field? In this direction, from positive to negative. Now let's say here I have made a small hole, here somewhere. It is like this. Fine. Now here there is a charge particle. Here there is a charge particle. If I keep this charge particle here, it's a positive charge particle. Due to this electric field, this charge particle will start moving till this distance. It will experience force. It will experience acceleration. It will be accelerated, right? The moment it comes out, here will be the last when its velocity will increase. From here the velocity will start increasing till here the velocity will increase. The moment it comes out of this electric field, the velocity remains constant because now there is no force which is being experienced by this particular charge. Are you yes or no? So now if I want a highly accelerated charge with a very high speed, I need to keep this charge in electric field for a long duration. Right? It is very simple. V is equal to U plus AT. If I want this charge to have a very high speed, V is directly proportional to time. If this charge is accelerated for more time, the more speed it will get. Or V square is equal to U square plus 2AS. For more distance, if this charge is accelerated, the more velocity it will get. So this charge should be in electric field for longer distance. There is a challenge in that. See? Now suppose if I increase this, here there is positive, here there is negative. This is the electric field. Correct? This is the charge. No doubt, this distance is increased. The force which is experienced by this particular charge will be there for long duration, will be there for longer speed, but it will not be able to gain a very high velocity because now since the distance between the plate has increased, the electric field has reduced. Due to which the electric force has reduced, due to which the acceleration which was put on this particular charge has decreased. There is a challenge. We cannot increase this particular length. We cannot increase the separation between the plates. The electric field will reduce. Now we need to get a highly accelerated charge. What to do? We need to keep this particular charge in electric field for a longer duration also, but we cannot do this. What to do? Here I'll write electric field will reduce. Acceleration will reduce. Will not be able to gain high speed, very high speed. So certain experiments were done, then the scientists came up with a machine. So in that particular machine, they are using magnetic field and electric field both. And with the combination of both, they are keeping this particular charge into electric field for a longer duration. Alright, because of which it is able to gain very high speed. Now let us study what is cyclotron. Clear? Cyclotron is a machine which is used to accelerate charged particles in very high energies, right? To very high energy. And then why we need this? To bombard with the nucleus to get radioactivity and all those things, nuclear reactions and all. Fine. So now we cannot do it alone in electric field because there are certain challenges. So we made a device, there is a machine in which both magnetic and electric field are there. How it is made? This is construction. Note it down. Construction. So first, this is a D. This is hollow semicircular conductor. It is a conductor. So there are two Ds. One is D1, one is D2. Alright, it looks like D, that's why its name is D. It is basically a hollow semicircular conductor. Now after that, here there will be a source. What is this source? From where we are getting charge. It will be a plasma, highly ionized gas or something, from where we are getting charge. Okay. So it is a source of charge. Then we have connected these two conductors with an AC supply. It is a very high AC supply. Very high voltage. Very high voltage. Around 10,000 volts. Around 10,000 volts. Clear? And the frequency is also very high. Frequency around 1 lakh to 100 lakh hertz. Very high frequency. That means in a second it is actually changing its polarity 1 lakh times. It is vibrating, it is oscillating. So this is also known as oscillator. This is basically oscillator which is connected over here. Clear? The frequency is so high that in 1 second it is oscillating 1 lakh times. It is changing the polarity 1 lakh times. That is why it is called as oscillator. Okay, it is oscillating. Now, then we have magnetic field. So this magnetic field is outwards, coming out of the board. Alright, draw it. Now then this is deflector. This is the exit. Clear? Now let's understand the working. So what happens is, I hope you have drawn this. Okay. What happens is, from here the charge will come. Okay. Now first, obviously this AC source is there. It will supply voltage. One will be at higher potential, one will be at lower potential. Let's say this is positive and this is negative. Okay. It is actually changing. It will be positive, then it will become negative, then it will become positive, then it will become negative. Here also, positive, negative, negative, positive, positive, negative, negative, positive. Like that it is happening because this is oscillator. It is an AC supply. Polarity changes, right? So now, initially, let's say this is positive, this is negative. When this happens, now this is the source of charge from where one charge will come out. Now, here, why this positive and negative is there? Because of this positive, negative, there is an electric field in this direction. Right? So, electric field is also there, magnetic field is also there. Now, since the separation is very small, the electric field is very strong. Very strong. Okay? And we have the potential difference, as I told, this is also very high, around 10,000 volts, because of which also the electric field is very strong here. Because of this strong electric field, this is negative. Negative plate will attract the positive charge. This charge will be attracted towards this. It will go inside with a high speed. It was at rest. The moment it became negative, and that too very high voltage, this force on this will be very high, it will be accelerated and going inside. The moment it goes inside, remember this story, the moment it goes inside, the electric field becomes zero. Why? Remember, in a hollow conductor, inside a hollow conductor, electric field is zero. Inside a hollow conductor, electric field is zero. So once it goes inside, the electric field is zero. Now it is experiencing only one field, that is magnetic field. Earlier, magnetic field was there, but it was not experiencing magnetic force because it was at rest. Because of this electric field, it came into motion. It went inside. The moment it went inside, the electric field, what it is experiencing, electric force, what it is experiencing is zero, because inside the conductor, there is no electric field. Right? And now, since it is in motion, it will experience magnetic force. And if you see, magnetic field is outside. This charge is going inside, perpendicular they are. And when charge is perpendicular to the magnetic field, it starts doing circular motion. So now here circular motion will happen. In which direction? Let's see. Right hand palm rule. Magnetic field. Velocity in the direction of thumb. Right? And then the direction of palm gives the direction of force. downwards. That means this will do a downward circle like this. Let's make a small circle. Okay. Now, the moment it comes out from here, no doubt magnetic field is there, but the electric field is so strong that it will again increase speed and zoom, it will come here. Very high speed. This electric field is strong. The moment it does half circle, it will come out of this D. Again, this electric field is strong. Zoom, it will come like this. Right? Now, see, this AC, okay, before this, let's say it has not come out yet. Okay. Some people will say, sir, this is positive, this is negative, this will ripple. So the electric field is in this direction. How it will accelerate in this direction? See, the frequency of this AC source is set in such a way, we know that this is AC. Polarity will change. This will become negative, this will become positive. It is set in such a way that this becomes negative when this charge comes out. Clear? The moment it comes out of this D, this will become negative and this will become positive. Clear? This AC source, this oscillator, its frequency is set in such a way that the moment this particular charge comes out of the D, the polarity reverses. Alright, now this becomes negative. Because of this negative, the electric field is in this direction. Because of which, the moment this charge leaves this D, it will accelerate very highly in this direction. Clear? Alright. Now again, the same thing. The moment it goes inside, electric field is 0 because inside a conductor, inside a hollow conductor, electric field is 0. It comes inside, again the magnetic force is there. Now this time magnetic force, magnetic field in this direction, velocity in this direction, the direction of palm gives the direction of rotation or direction of force, upwards. So this will rotate upwards, but the radius of this circle will be greater than this. Why? Because now the speed with which it entered this D is more than this speed. Because here it accelerated one time, right? It is having some speed. In magnetic field, speed remains same, only the direction changes, right? Here, it is there with the speed which was there here. Then again this acceleration. Because of this acceleration, again it will accelerate here. Zoom. The velocity increase. Because of increased velocity, this radius will increase. R is equal to mv upon qb. Are yes or no? In the last section, we saw that R is equal to mv upon qb. So if velocity is more, radius will be more. This circle will be of more radius. Again, the moment it comes out of this D, the frequency is set in such a way that this polarity will again change. This will become negative, this will become positive. So now this plate is negative. The acceleration, the force will be in this direction. The acceleration in this direction, zoom, with very high speed. Now again, the velocity will be more than what it was there here, because again it is accelerated. Again, this circle will be of bigger radius. It will come out, zoom, then again bigger radius, zoom, again bigger radius, zoom, again bigger radius, zoom, again bigger radius. A time will come when this charge will have the radius same as this particular D. It will come along this, okay? Again this zoom, with high speed, it will come along this, along this, along this, along this, and then again this electric field, because of this, it will go straight. This deflector is there, which will deflect the magnetic field in this region, so it will not do a circular motion, it will go straight and exit with a very high speed or very high energy. Clear? Very high energy discharge will come out. I hope you understood. Not at all. See, understand the oscillator frequency or the frequency of this, how it is rotating. We know that time period is equal to 2 pi m upon qb. It is nowhere related to the radius or the velocity. Once the time period is set here, the same time period is for this charge also, the same time period is for this AC supply also. See, it is independent of velocity and radius. That means how much ever you increase the speed, how much ever you increase the radius. It only depends on the mass and charge. Since we are talking about the same charge, the mass and charge will be same. So the time period in which it is completing this circle will be same in which it is completing the bigger circle. The speed is more. If the speed is small, it will complete this circle in some time. In the same time, it will complete the bigger circle also. Because now the speed is more. Clear? So this AC supply is set in such a way in which it does half cycle. In half circle, this will do half cycle. See, AC supply is something like this. It will be positive for half cycle, it will be negative for half cycle. So in one complete cycle, it is changing its polarity 2 times. Here, see, this is half circle. So in half circle, I want negative. In other half circle, I want this as positive. That means in this half circle, I want this AC. Sorry. In this half circle, I want this AC to change its polarity once. AC changes its polarity once in half cycle. Here also we want in half circle, the AC should change the polarity. That means in one cycle, AC changes polarity 2 times, and in this cycle, this will complete one circle. So the time period of this particular charge should be same as the time period of this. So that when it does half, it also does half. Clear? In half, it should change the polarity. So the time period of this and time period of this is same. So initially we'll set the time period of this AC in this particular time period. All right? And how much ever speed, how much ever radius is increased doesn't matter, because the time period is same. In the same time it will complete this half circle. In the same time it will change its polarity. In the same time it will complete this bigger circle. In the same time it will again change the polarity. So when the charge comes out of the D, the polarity is set in such a way that it accelerates in the same direction in which it is moving. Clear? We'll come to this again. Don't worry. I hope you understood. If you want to write the working, you can write down. The electric field accelerates the charge until it enters D2. This was D1. This was charge. This is D2. Until it enters D2, the electric field will accelerate. Okay. When charge enters D2, it only experiences magnetic field because inside a hollow conductor electric field is 0. The magnetic field makes the charge move in circular path until it exits D2. The moment the charge comes out of D2, polarity of D switches. D1 becomes negative and D2 becomes positive. So now the charge gets accelerated towards D1 and enters in D1 with increased velocity. Clear? Till here note down, or if you want you can take a screenshot of it. I'll go out of the screen, take a screenshot, I'll count till 3 and come. 1, 2, 3. Alright. Now next, then what happens? Again inside the conductor, D1, the charge experiences only magnetic field which makes it move in circular path until it exits D1. This time the radius of the circular path is bigger than the previous one because the velocity was higher than the previous. When the charge exits D1, the polarity of the D's again switches. D1 becomes positive and D2 becomes negative, and the process keeps repeating. Clear how cyclotron works? The velocity of the charge increases after every half circle, so the radius also increases, and finally the radius becomes as large as the edge of the D, and the charged particle is made to move out using the deflection through the exit. Clear? This is what we understood just now. You can again take a screenshot of it. 1, 2, 3. Alright. Understood? Just read it again. Try to make the diagram and understand again the working. Once you understand the working, this question, it comes in boards. They will ask the construction and working in boards, and the marks will be also good. 5-6 marks it will come. And it is a gifted question. Once it comes, if you have understood it once, you will remember the working lifetime. Because it's pure story, right? And it's pure logic. Clear? So understand this properly. If it comes in exam, you are blessed. Next. Okay, this is fast moving charge which is needed at the end. You can note it down. Now, energy of Q when it comes out, energy of the charge when it comes out of the cyclotron. How much energy will it have? Since it is in speed, the energy what it will have is kinetic energy, that is equal to half mv square. Half mv square. Alright. From here, what is the V? R is equal to mv upon qb. R is equal to mv upon qb. So V is equal to qb. V is equal to R qb upon m. See, once the charge is going in the cyclotron, before only we can get to know with which energy, with which speed it will come out, by the radius of the d. Because at the end, the radius of the circle, what the charge is doing is the radius of the d only, right? And the value of charge we know, the mass we know. So we can initially also we can get to know by which velocity it is coming out. Okay. Now this we will put here. So this will be half m r q b upon m whole square. That is equal to half. Now this m and one m will be cancelled because it is square. This will be r square q square b square upon m. Let's write it as r square q square b square upon 2m. This is the energy by which the charge will come out of the cyclotron. Clear? No need to learn the formula. Formula is half mv square and radius is mv upon qb. From there get the v, put it here and get the energy. Alright. Next, time of Q, time of charge for circular motion and frequency of the AC supply. So time period we know 2 pi m upon qb, right? It is independent of radius, it is independent of velocity. So this will be the time for circular motion for charge. What will be the frequency of AC supply? I already explained you the frequency of AC supply should be same as the frequency of charge. Here, this is for charge. Okay. Time period for charge. Time period for charge. That is equal to 2 pi m upon qb. From here I can write frequency for charge. That is equal to 1 upon time period, that is qb upon 2 pi m. Right? Now the same frequency this AC supply should have. I hope you understood. Clear? Let me explain you once again. See here, in one time period, this particular charge will do a complete circle. That's how the time period is. But here it is only doing half circle. That means in half time period, this particular charge will come out. In half time period, this charge will come out. And in that half time period, this polarity should change. Earlier this was negative, now this has to be negative. So in AC also we know that in one cycle, this changes polarity 2 times. I want it to change polarity once the moment this charge comes out, and it will change polarity once after half cycle only. That means in half time period this is coming out of D, and in the half time period the polarity should also change. Right? So the time period of this circle should be equal to the time period of this. That means the frequency of this charge should be equal to the frequency of this oscillator. Clear? So now frequency of oscillator or AC supply is equal to frequency of charge. That is equal to QB upon 2 pi m. Very important. Clear? Clear? Now, next, limitations of cyclotron. Limitations. See, one limitation is we cannot accelerate neutral particle, right? Cannot accelerate uncharged particle like neutron. Because if I keep this in electric field, it will not experience any force. Why? Because in electric field, only positive or negative charges will experience force. Okay. Second, cannot be used for very small charged particles like electrons. Why it cannot be used for very small charged particles called electrons, like electrons? See, we know that if the velocity becomes very high, mass changes. I hope you know this. In the very first chapter, we discussed about m is equal to m naught upon under root of 1 minus v square by c square. Our mass is basically depends on the velocity. This is the rest mass when the velocity is zero, right? When the velocity increases, the mass starts varying according to this particular formula. Correct? But when we run, we don't experience a change in mass. The reason, this is v square by c square. C is the speed of light. So our velocity cannot become comparable to the speed of light, because of which this term remains zero, and this is m naught by under root 1, that is m naught by 1. So m is equal to m naught. So if we run, our speed cannot become comparable to the speed of light because of our mass also. But once we are talking about very small electrons, very small charge, the speed becomes comparable to the speed of light, because of which this particular term will get some value, right? Let's say this term becomes 0.7. Okay, so if this becomes 0.7, so what will happen? This will be m naught upon, m is equal to m naught upon under root 1 minus 0.7, that is 1 minus under root 0.3, that is equal to m naught upon 0.5 something, 5.4 something it comes, that is around 2 m naught. That means what I'm trying to tell is, if the velocity is increasing, if it becomes comparable to the speed of light. So this is one example. See here, the mass has changed. For this example, the mass became 2 times. Now what is the problem in this if the mass is increasing? So here what will happen in the cyclotron, the charge is moving, the speed is increasing. A time will come when the speed will be as comparable to the speed of light, and then the mass will change. In that process only the mass will change. If the mass changes, the time period changes. If mass changes, time period. Okay. And if time period changes, frequency will change. So now the charge is moving with a different frequency, and the oscillator's frequency was set at the first. Oscillator's frequency was set by this formula, right? 2 QB upon 2 pi m. But in the middle only, the charge mass has changed because of the change in velocity. The frequency of the oscillator remains same, but the frequency of charge changed, because of which the charge will not be in sync with the oscillator. We have set the oscillator in such a way that once the charge does half circle and comes out of the D, the polarity should change. But now the time period or the frequency of the charge is changing. The polarity will not match the moment it comes out. It will become unsync. It will not be in sync. Okay? Alright. If you want, I'll write it down here. The charge will not be in sync with the oscillator. Alright, I hope you understood this. That's why we don't want to put any kind of charge such that their mass changes once we put it in the cyclotron. So now which kind of charges we put in cyclotron? We'll put proton. Proton's mass is of the order 10 power minus 27 kg. Electron is 10 power minus 31 kgs. 10,000 times lesser than proton. Very small this is, right? We'll put proton, alpha particle, those kind of particle we'll put in the cyclotron. Clear? Cannot be accelerated to the speed of light. We cannot accelerate it to the speed of light. Why? Again the same reason. The same reason, m is equal to m naught upon under root 1 minus v square by c square. If this becomes the speed of light, 1 minus 1, 0, mass will become infinity. Again the time period will change, it will become out of sync. So because of which we cannot accelerate any charged particle to the speed of light using the cyclotron. Okay? I hope you understood these three limitations. Fine. Just revise today's session. In this session, it was only this much. In the next session, we'll be seeing, okay, in the next session, we'll be seeing Biot-Savart's law. Biot-Savart's law. Clear? And we'll be seeing magnetic field due to wire, due to a current carrying wire. Due to a current carrying wire. Alright, we'll be seeing current carrying wire of infinite length, of finite length, different questions also we'll do. So this is what we are going to do in the next session. Alright, I hope you liked today's session, you understood today's session. If you like today's session, do press the like button, share it with your other friends who are preparing for their boards and competition as well. Subscribe to our channel and do not forget to click on the bell icon so that you never miss any update from us. Alright. Do visit our website www.v-learning.in. You will be getting all these sessions. Along with that, you will be getting lecture notes also for each and every session in PDF format. You can download them, you can learn from them. They are very useful for you. Okay, we'll meet up in the next session. Till then, keep learning from V Learning. All the best.